I am here today with Steve Musick. He is the Smart Manufacturing Engineer with the Smart Learning Factory at Purdue Polytechnic. Thank you so much for joining me today, Steve.
Oh, no problem. Thanks for the invite.
Absolutely. Yeah, so this is an exciting new addition to the Smart Learning Factory. This is an automated storage and retrieval system at the factory. Tell us a little bit about how the ASRS works and how this sort of partnership with Element Logic made this happen.
Absolutely. So just a little background about the lab as well. I don't know how much you may have seen or heard already, but at Purdue right now, we're in Purdue's newest building, and with that, our School of Engineering and Technology, we built 4 brand new labs in smart manufacturing. So we have our Smart Learning Factory where I'm at today. We also have a continuous process lab, an industrial IoT/PLC lab, and then a smart foundry in the basement of the building. And really the goal of all this is to give students that exposure to an industrial environment and kind of the emerging technologies in manufacturing and in industry, but give them that exposure at the undergraduate level in classes. And so all of these facilities, they are industrial grade equipment, and we're particularly here in the factory, we are running this as a production factory where we are building product from beginning to end. And so the goal is that we would give students a snapshot of all the different facets in a manufacturing environment. So logistics and material handling, component manufacturing, assembly, data, and then also from the IT side, data science, cybersecurity, all of that. So in particular, kind of with the logistics warehouse that we got set up here, we wanted to be able to have a piece of the factory that caters to our industrial engineering students and our supply chain students. But then kind of beyond that, it will actually be a functional warehouse in that it will store goods and parts that will service the rest of the factory and the rest of our smart manufacturing labs here. So the way we're going to have this set up is we're going to have our AutoStore system, it'll be set up just behind me here. That will have roughly 100 bins for storing parts for the products that we build or for maintaining the equipment. And we can either retrieve parts from those manually, just like a regular AutoStore system would. But then we are also building in additional transfer ports so that we can have bins being picked up by AMRs. And those AMRs then can automatically deliver parts to the assembly line or deliver parts ultimately around the building, including taking an elevator down to that foundry to be able to pick parts up and move them around. And so we really kind of wanted to give, create something that, where we have material flowing in and out and allow students then the opportunity to see what the latest technologies look like and then have the opportunity to optimize them. Most importantly, everything that we have up here, nothing is optimal or working efficiently. And so that is where incumbent upon them, the students, as they take classes, to start taking ownerships of pieces and parts and all this and try to optimize it, make it better, and add to it.
Absolutely. Would you say, because you've kind of like gone over kind of the whole like swath of manufacturing, does this give them access or sort of hands-on experience with everything from, like you mentioned, PLCs to like robotics when you have to work with an AMR? Like kind of walk me through, a student can sort of access a whole like factory, it sounds like. Walk me through what that looks like from a student's perspective.
Yeah, absolutely. The goal is exactly that. We're trying to give them exposure to all the different areas, no matter what, whether they're mechanical or electrical or industrial or end up going computers, engineering, whatever it may be. Definitely give them that exposure to all of the different aspects here. Most importantly, to see how a modern, kind of factory of the future, how all of these things are interconnected and work together. So yeah, within classes, yeah, they have, we have, as we said, you have robotics, PLCs, conveyors, now an AutoStore, CNC, ton of, CNC and machine equipment. The goal is that we give students the exposure to this technology and let them work with it. Not just to train them on how it runs and how to operate it, but we let them, get that experience with operating it and the trade craft that comes behind all this too, so that as they are then actually get jobs as the engineers that are going to be installing and optimizing work on these systems, they have that hands-on experience of having done all this before. So yeah, the goal is that, particularly here in the factory, our goal is that over the next few years as classes come online, a student could be in here, could be taking classes in here all 4 years. Sometime, starting off maybe almost as like an operator on our assembly line, but then by senior year, they're managing kind of a portion of it and working on projects in that.
Absolutely. Yeah. I mean, is that kind of, a part of Purdue's philosophy in terms of making sure that when an engineer leaves the university, that they're prepared across the board to, kind of tackle very hands-on tasks when they go out into the careers?
So yeah, this and that brings up an interesting point, because actually at Purdue we do have we kind of have two separate divisions, if you will. We have our College of Engineering, which actually I'm a 2-time graduate of. My degrees are in mechanical engineering, and that the College of Engineering tends to focus a little more on the theory and the design analysis. Again, nothing wrong with that. I loved every bit of that. But definitely a heavier emphasis on the theory, physics, first principles, the mathematics on all of this. Then our learning factor here, we're part of the Purdue Polytechnic College. And within that, we have our School of Engineering Technology. And within engineering technology here, our focus is about a 50-50 blend of that theory and the hands-on applications. So, whereas, like in the College of Engineering, where I learned linear algebra just by, taking math classes. For example, here, students, they'll take robotics classes, take a robotics class, learn how to operate robotic arm, learn how to operate the teach pendant, everything like that. And then through that experience, back out the linear algebra and the math behind it all. So that is kind of, we have a differentiation there. Both approaches are fantastic. But yeah, definitely within our School of Engineering Technology and the Purdue Polytechnic in general, our slogan is officially, industry ready day one. Just based upon that, getting that hands-on experience in working in industrial environments before you graduate.
Absolutely. The new ASRS system that, I think it was just announced a couple of days ago. Are the students coming up in the fall going to be the first ones working on that? Are there already students who are experiencing the automated system in the warehouse?
Yeah, so that we're expecting the installation to finish later this summer. So our hope is that by the end of August, when the fall semester classes start, that will be up and running. I have a few student workers working with me this summer, so technically probably they'll get the first exposure to this, as they're just like me, will go through the trainings and how all this works and operates. But then, fall will be kind of when classes will be able to start utilizing it.